All right. Good morning, good afternoon for me at least. I was asked to give an overview or some kind of talk about Gentoo Prefix, a project that I've been working on for quite some time. It is a bit much like the previous speaker, but more from a Gentoo's perspective, which is a Linux distribution. Um, all right, so something about me. Like I said, I've been involved with Gentoo for quite some time. These numbers actually tell me I'm getting old. Um, anyway, in a very brief nutshell, I have some origins in research in the Netherlands. At CWI, Centrum voor Wiskunde Informatica, and I had a need there, of course, to try and get software compiling on the systems that they had. And I also had a personal need that was that, I really like to use Vim and Mud, which is all very much console style, but Mud is very often not even installed. It's an email client, and Vim is usually out of date. So that is a bit why this is so interesting to me. So it has been both professionally in the past and it's always been personal. Just a small note, my current employer has nothing to do with Gentoo Prefix or anything that I do for Gentoo Prefix. They think it's fine, but in no way they have anything to do with it, which I just wanted to make sure that everybody understands. This is purely Gentoo and me as a volunteer Gentoo developer. So a bit more. And why did I start on this? Why? In short, in the past, and these days it's getting much better. But in the past, if you were working on Solaris 9 or Solaris 10, or you were working on macOS from the early 10 days, you would find that your environment that you're working on is pretty much out of date. And if you're working into a cluster that was set up by whatever IT department they used, whatever in those times still Red Hat Linux of a version that was at least a couple of years old, there's also no way of changing this, right? Upgrading your Solaris install is not just a possibility. So you're basically stuck with whatever there is, and that's either for political reasons or just because the hardware is old. But you do want to use more recent, more decent development tools. And I've always been very interested in development. Getting yourself development tools like compilers, but also the utilities like sed and stuff like that. And most of these things you can just compile, even on, let's say, outdated operating systems or hardware. Even today, on very old hardware, on very old configurations, you can still build a recent GCC, for instance. And that was interesting because you sort of prolonged the life of whatever hardware you had to buy or whatever hardware you had available. And one of the prime examples there was, that my first Mac I ever bought, which was a MacBook, I think, or it was called a Power Mac or a PowerBook or whatever it was called. Anyway, something extremely old, having something like 500 megahertz. And yes, it was running Jaguar, which is someone at that time actually made a Gentoo logo that was using the leopard and Jaguar skin, which is here on the slide. But what we did with Gentoo for macOS X was actually installing software right into the host system. So we just put it next in USR bin next to the other tools. And that was cool for everything that was missing. But of course, it was extremely annoying when there was already something there, like Vim, that was outdated. So you could not replace it. Yeah, you could do that, but then you would damage your system somehow. For Gentoo as a whole, Gentoo for macOS was also not so nice because there were all kind of exceptions that had to apply for the macOS port, and that is what is really well, people don't like that. So in Gentoo, there's some sort of shell scripts that define how you're going to build software. And you add a lot of if cases, basically. So that wasn't really working very well. So very quickly, we came to whatever this project is, Gentoo Prefix, which basically was the decision to say, you know what, instead of trying to install into the root file system or something, we just dedicate a directory somewhere in an offset, as we call it, and that directory can be in your home directory, can be in your var temp, can be on some scratch or on an NFS, anywhere where you want it to be. Because it is a directory anywhere, we don't need anything like root access either, so you can even do this on the cluster of your university or wherever, or on the desktop that you got provided from your employer where you don't have root access. And because you install everything in that clean slate, basically, you can replace anything that you want, as long as it is possible. So you can provide build tools, you can provide compilers, you can actually provide a complete toolchain, including a linker, which means that you actually can work around a lot of problems. Early editions of macOS, for instance, had a compiler that was full of bugs. And just providing a fixed compiler basically made life considerably better when you try to install software that did not want to take into account a broken or weird compiler. But yeah, so this was not limited at all to macOS. This was just like, okay, we put everything into a different location. That is basically the approach that you see more people doing, with like Homebrew and MacPorts. They all use some sort of offset. But what is, I think what makes Gentoo Prefix different, or considerably different from most of the other approaches, is that Gentoo Prefix is very much focused on providing its own toolchain. And a toolchain means a compiler and a linker and everything around it. And it's not so hard, or well, relatively speaking, it's not so hard to build a compiler. On certain platforms, it is actually very tricky to build something like a linker. But that's not where it is. The thing is that if you build just a compiler, it doesn't mean that you suddenly have something that really masks that you're working into some offset location, that you're shadowing tools that are available on the system or something. So what we do, and we do that from day one, because that is really something that's very important to us, we configure the compiler and a linker in a very special way. So we support basically a couple of compilers, and we try to do exactly the same for all of those. We definitely support the GNU binutils, which is used on ELF platforms, and we actually work with the Apple CC tools, which provides you the linker and the assembler. And we patch them in the same way, or we use wrapper packages. So to just give you an indication of why we need to, or why we want to do that. This is, I do a lot of C programming, so this is for me, we are compiling something. You're compiling a C file, you want that to produce the executable my app. but you actually use something like a library like libyaml. Well, okay, so if you compile this, then you need to add that you link against libyaml. After you install libyaml, you can use a native package manager, whatever. And this is the normal way of how you do those kind of things, right? You install the dependency and then you tell the compiler, okay, you can use this library, and then you get basically your application. This can work. That is like, this is just working because everything is right. This can fail because it cannot find the required include file because, well, either you did not install it or maybe it was not installed in a place where the compiler knows where to look. It can also fail because the linker is actually looking for the YAML library and it cannot find it for the same reason. It was installed in a different place or it was not installed at all. And the worst case, which is usually also the most nasty one to resolve, right, is that it actually fails to compile because it thinks there's something different, which is usually what's happening when you have different versions of software that then sees different versions and it doesn't compile anymore. So yeah, what you can do is you can, of course, manually install then your library, let's call it myYAML, and then you tell explicitly to your compiler, hey, here you can find where you can have the headers for myYAML, and here you can find the library for my YAML thing, and then you link against it, and that works fine, right? Because then the compiler can find everything, and you explicitly told it where everything is. Yet if you run the executable, suddenly you get a trap because it cannot find the shared library that it needs to execute this. Because it is not in a standard location, so it doesn't know where it needs to find it. If you Google for that, then you can easily solve that, set LD library path, and that works until things get a bit complex, because then suddenly it starts to break things. So the real solution for this is actually to use things that are called run path or rpath instructions that you can put in ELF binaries and libraries. You can also add this path where you install the libyaml library to your ld-so-conf on Linux. Then you need to have root access. So you can solve this, but it's all manual. And that's exactly what the Prefix Toolchain tries to avoid. So what it does, it is actually modifying the compiler to, by default, look into this prefix, the offset, the specialized offset that we created, this directory, to look in there for the includes, such that everything that we install in that prefix is automatically seen, just as if it were installed in the main system. It actually tells the linker in whatever way is necessary to look also inside this offset. So it actually finds the libraries that we installed in there. And in accordance to that, it also adds these instructions such that when you have the build binary, the build binary itself can execute without any help, without any changes or environment settings or something like that. And it can do that through these rpath expressions, for instance. This is all transparent. So the software that you're building doesn't see this happening. It doesn't know this, which is good in a way, because that means that, transparent means that you don't have to fix programs or fix other kinds of software that you want to install, because it just works this way. And in most cases, this is indeed enough. Now, to indicate that this is not as simple as it sounds, if you want to support multiple targets on macOS, for instance, in recent versions of macOS, there is an SDK, there's no longer USR on the system with lib or include. So we tell the compiler, and the linker actually to look into this SDK path, which is some long path, can be configured during whatever kind of installation of Xcode. So we do something special there to make sure that it finds it, and that basically you as Gentoo Prefix user don't have to bother about it. There is actually a quite difference in how the linker responds. The Solaris native linker also, for instance, responds quite different to the GNU linker. Yet most, most C projects, open source projects in particular, intend to assume GNU LD. So we add flags like search pass first to basically emulate the same behavior as we see with GNU LD. Which also just makes it much easier to port programs, right? Well, in the Mac file format, you don't have this RPOF. We actually have RPOF in recent editions, but they actually record full paths, so they don't have the problem that we have with ELF. So that's nice, but it also means that in that case, it actually isn't doing anything special there. So basically, it contains all kinds of alternatives that it knows for the current path, such that from a usage point of view, as a prefix user, it works the same on a Linux host as it does on, for instance, a macOS host. Yeah, so basically how we would do this example that I had before is in Gentoo there is a tool called emerge. Emerge is basically the tool that like opt, get, or install, or it is EUM, that the one that you just say, I want this package or remove this package. So in our case, we just emerge YAML or libyaml, whatever it is. It will do its thing. It will from source compile the YAML. It will install it, all set up for the video offset directly in the prefix. And then I can just run this simplified GCC compiler command, compile my application, use YAML, and the resulting application will run because it is just, so to speak, fixed to the right YAML that comes from the prefix location. Even if there would be one in the host system, it would ignore it. It will look at it. So that is pretty transparent, and that is pretty nice. But yeah, we need to do some tricks for that, and that's why we always have a toolchain. So we always provide a compiler and something that does the linking. Without it, the whole thing falls apart, of course, because then suddenly compiler cannot find headers anymore, or the linker cannot find libraries anymore, or whatever, for whatever magical reason it does work, but then it fails to run. So like I said, with this, most simple is not even true, but most packages that don't do anything specific like detecting compilers or figuring out on Solaris there is a USR SFW path, and all those without all that kind of trickery, most things just work, which is pretty good. Because that means for free, you get everything that respects your offset prefix and grabs all the libraries from there. Of course, there is these things that are actually trying to be smart, such as CMake. CMake is an all-time favorite or horrific thing. What was wrong with autoconf? It was too slow. Okay, so you create something new. And then, of course, you create something that is trying to be smart. So we need to patch most of that smartness out of there such that it just respects, hey, look, there is an offset. In this offset, you find all tools that are sufficient, correct, up to date, having the patches that you need. So please don't try and invent something yourself. And if you've done that, right, then there is many people are looking for development when they look at Linux. That is not totally the same. It's not always POSIX compatible. If you try to port something to macOS or Solaris, you will find that there's differences, and sometimes you need patching. That is ordinary porting. You always need to do it with the yeah, I would say popularity of macOS. The macOS porting is rarely necessary anymore these days, right? Because all people already have the patches in there. They already know that it's there. It's also much easier these days to run it. Solaris, yeah, as long as you stick to PostFix, it's fine. Not so interesting for people anymore as a platform these days, but okay. The amount of porting that you really need to do for platforms is really low. Realistically speaking, these days, it's almost never. The times that we had to do something because we had a CPU that wasn't quite working with unaligned access or something, that's really over. You rarely see issues with that these days. Yeah, so basically, Gentoo Prefix lives on top of another operating system, on top of another distribution. We call that the host. The host is what we live on top. Yeah, the first perspective that we have on the host is that we accept that it has a kernel, it has a C library, libc, right? And the rest we all try to provide where possible. C library for us also includes things like the math library and which is the real time, those kind of things all belong to, okay, they are part of the system. We cannot replace those very easily because we don't always have the sources available, or we just think it is incredibly complex to get that working and we don't really need to. Especially Solaris and macOS have, during their releases, extremely stable APIs to kernel and the C library, unlike Linux, that you never know, there is no version of Linux that represents to something. There is something like CentOS 7 or CentOS 8 or Debian whatever, but it is not, that is all different distributions. So it's harder to manage. And that's why we have a special view on Linux hosts, where actually, in the end, it turns out that we cannot replace kernel because we don't virtualize, we don't use root. But we can actually provide our own C library because glibc, well, it's all open, and the build, yeah, Gentoo knows very well how to build that, of course. So we can do that. That means that on Linux host, we can go one step further and even provide our own C library, which makes porting of applications on especially older hosts much more simple. It comes with a downside, of course, that you're no longer compatible with the host system. But okay, if that's not your goal, then it allows you just to install and run the software on an old system, so to speak. Yeah, so we call this, it has a name when we actually use the C library glibc on a Linux host. It's called RAP. RAP stands for Wrap Aim Prefix. It actually is, but well, it isn't as well. It works well on very ancient systems. The good thing is that you don't need RPath tricks because the glibc comes with its own LDSO, which is the runtime linker, which is basically what we do is every binary we create, we tell it in its executable or interpreter to use our own runtime linker, and that runtime linker knows where to find stuff. It actually reads it from its own ldso.conf, which is a very nice trick because it hides even more the details of what you're doing, and we can even use more native streamlined versions of the linker, for instance, because we don't have to patch it. But yeah, so that's something that's really nice. It's a bit more native, and it allows you to do more things just because you can upgrade the libc. Yeah, so just a little bit about, okay, what do we support today? let's start with the sad news. In the, I would say in the past we supported things like AIX, HPUX, IRIX. There even was an Atari port. That's all really cool pet projects, but the reality is that no one has access to these things anymore. And even if you do, there is absolutely no use for it anymore. It is all so slow, it is impossible to work with. And it costs a lot of resources to maintain them, especially target like AIX is always different, always problematic. So we don't do those things anymore. The things what we actually do these days are Linux, macOS, and Solaris. They are fairly well supported. We run over a couple of versions of macOS, and just because I find it very fun, I even keep an old G5 machine in my basement that I run the PowerPC macOS, what is it, 10.5 on, but that still works fine, right? So we compile GCC 10.2 on that thing, and we compile our own linker, and then we have an environment that is almost identical to what we have on our latest macOS system, and that's really fun. Well, yeah. Linux support has the big advantage that it gets all of the support from Gentoo main. So Gentoo runs itself on a plethora of architectures, ARM, PPC, PPC-LE, RISC, V, whatever, you name it, they do it. In principle, in Prefix, this is all inherited. If you have a running Linux system on whatever, let's say PowerPC, as I know some of you do, you basically, if you need any patches for that, if you need any patches at all for that, I would say you get them straight from Gentoo mainline, because we are just about providing the base, the toolchain, and for the rest, we really rely on Gentoo mainline. So most of the packages and stuff all comes from the vast base of Gentoo developers that works on keeping those up to date and making sure that they are actually behaving and working and installing exactly as you want. Yeah, so a little bit, this is something that I dug out of a very old box, I would say. It basically shows 6 years of where we track the amount of packages that we would support, and in the right, it's very small, the legend, but it basically lists a lot of platforms that I had at that point available, and yeah, I was able to access even, which includes a couple of the Windows platforms, and well, anyway, the Mint one is the Atari one. The fun out of this whole thing is that if you look at it very carefully, you see that on the left, when it all started, the PPC macOS one was the top leader, and it actually towards the end still is. That is, of course, because that was my Mac. Yeah, the Linux ones that jump in somewhere at 2008, that is because we joined it with the main Gentoo tree, and of course we inherited all the Linux support, which originally was all x86, and then at some point AMD64 took over, of course. Anyway, that's just a bit about the way that we grew. Nowadays, what we do is, yeah, we try to be as much as possible staying along with main Gentoo. So the few things that we need to change that we could not bring back yet, only those we keep. Yeah, we only try to support what we think we can. So we drop all kind of platforms that are fun to have, but we can obviously not support anymore. And yeah, there's some semi-automated bootstrap results, which means we just test whether or not the whole process of bootstrapping works. Bootstrapping means you start downloading source packages and compiling them, and gradually you build up more and more tools. such that you can actually have the Gentoo package manager, this merge thing, which is called portage. And once you have portage, we actually continue using portage to install package one after another in a very careful order, because there's dependencies, of course, and we try to avoid these dependencies all the way up to the point that we can tell the package manager, hey, why don't you reinstall everything and bring yourself up to what you consider is a system state. And then basically at the end of that, everything is so what we call self-provided. So that means that everything is using the tools that were provided from the prefix itself, up to the minimum requirements from the host, of course. This is a process that takes a couple of hours. I think on the fastest machines, yeah, it is something within really a couple of hours, but it's compiling a lot. It's compiling compilers that take a fair amount of resources. Just to give you an idea, on the old PowerPC Mac, it takes something like 8 days to complete this whole process. You don't have to do this very often, of course. You only have to do it once in principle. But it is a long process on old hardware. On new modern hardware, this is all not that long, but it takes a fair amount of computation, compiling of the sources. But then everything is ready and set for your environment, so to speak. So Gentoo Prefix, it is part of Gentoo proper. It is an official sub-project. We still have some separate stuff because we need to override certain packages, and we don't know yet how we want to do that for real. That sounds more severe than it is. Like the compiler changes that I mentioned and the linker changes, that just needs careful testing and careful documentation and careful arguing, because the main Gentoo maintainers are not too happy about just accepting something like that if it isn't tested. Now, we have tested it for quite some time, but of course we also need to test the effects on normal Gentoo systems and to make sure that we really don't mess with anything. So those are the things that we currently have aside. This is not an issue for the RAP targets or more native targets, because they don't have most of these integrations necessary. So long story short, there has been some documentation tracks where which we call EAPIs. There are enhancements, request documentations about that basically that just defines that these build scripts, which we call e-builds, which are shell scripts, they have some variables available to them to say, hey, this is the offset location. So should you need it, should you need to tell here you need to look, then these are these variables, and that's all defined, and that's in there for a couple of years now. So I would say that is well accepted, and we are slowly integrating the remaining work that we have with the main Gentoo repository. So we have a website with some information about how we do it, what we do with the platforms that we have. That is well, nice for some reading. We have the general bug tracker, for which that's the best way to, if you find issues or something, the best way is to report them there. I will not promise that you get instant responses, but I always try to at least figure out if there is something simple to do or not, or that we need some help. Because obviously we have a lot of weird scenarios. If you have a system administrator that configures his system very weird, in a weird way, it may be that we just don't know things like Perl or Python, try to figure out themselves a lot of things, and they might just get confused, and that's a situation that we cannot easily reproduce. But in general, I think things like bootstrapping on CentOS or Debian or Ubuntu, Arch Linux, they all go fine without too many issues. So But anyway, yeah, if you have an issue and you want support and you cannot find it through IRC or whatever, you can just file a bug here. And that's basically all I wanted to say about yeah, the history of the project and where we are today and what you can do with it. So thank you.
Thank you for that talk, Fabian. If there are any questions and you're in Zoom, and to Kenneth first.
Let me enable my camera again. Okay. I have a couple of questions actually. So if somebody else has questions, feel free to interrupt me so other people get the chance as well. One thing I was wondering, you mentioned CMake as being, how did you call it again? Horrific. I agree with you. So it does a lot of things under the hood. It tries to be very smart, and yeah, if you're not in whatever environment that they expect you to run, and then you're in trouble, yeah. Which is of course the case in Gentoo Prefix. I've seen the patching you do to CMake. I've looked into it a bit myself as well. You have to explicitly tell it not to look in user lib and has all these hard-coded stuff in there. Have you tried or have you considered contributing some of those patches back to CMake so it has an easy option that says, look, whatever you think is sensible by default, don't do it and just only look here and don't look anywhere else?
Yeah, so the problem, and CMake is not alone in this. Python is another extreme example of this. And what Python devs, for instance, say, screw you, go away, we don't care. We only support a vanilla machine. That's what we built for. And if you do something else, then we don't support that. We don't want to support that. We don't want to think about that. And from their point of view, honestly, I can sort of, that makes sense to me. I honestly think for Python, you know, they try to do too much. They should rely more on distributors, but okay, they don't, right? And CMake does the same thing. And I think that's also because of their, they're a commercial company basically providing this. And I think they have an approach here. It's the same with Adobe's Boost, and they have an approach that is just like, we want to compile it on those systems and then use it to do whatever we do. So whatever we say, they're reluctant to use our patches because they just feel like it complicates stuff. We don't care about it. You shouldn't be doing this. So the only solution then is, and yeah, that is why Gentoo is a meta distribution. Is to patch the sources to our liking to make sure that they do what that they are usable in our environment. And I think that is the great thing, mentioning Python and CMake. I think there isn't a single distribution out there that does not apply patches to these kind of packages. And they all do the same. So these vendors know very well that they do not work in any realistic scenario, but they don't care, right? Because it's not their intended output, and everyone patches it anyway. So the problem is solved, right?
Yeah, the problem is moved to the maintainers of projects like Prefix.
Try to get everything back to the maintainers, which we call upstream. That's for most of it. But many upstreams. There's two types of upstreams. One is like, oh, thank you, that's great, wow, no problem. And there's others that say like, yeah, but I don't like this platform and I don't care, or yeah, can you sign this thing? And oh, well, I think this is difficult, maybe in the next week. So yeah, what can you do?
Yeah, okay. And then I see Bart has a question as well, but I have one that I think is important. So you mentioned the bootstrapping procedure for Prefix, where you build the toolchain carefully basically from scratch up until you get a working portage, and then you can emerge everything you want or need to. What we're doing I don't want to spoil Bob's talk, who's coming up next, but what we're doing is in the Easy project is we're bootstrapping in, for example, a CentOS 7 virtual machine essentially, or a container, doesn't really matter. And then we're using that bootstrap prefix on other operating systems that are similar. So in Debian, for example, or other Linux distributions, but we do stay to the same architecture. So if we bootstrap on x86, of course we stay on x86. Is that something sensible to do? Or do you say he'll have to be careful because things may be picked up from CentOS that do not work on Debian?
No, so I think maybe this is interesting in a way, but so what we did, so what you're doing is nice, is interesting, and I think especially when you provide the libc, then actually this will work very well, because the only interface you have is with kernel. So kudos for that. What we so Gentoo can also do bin packages. This is slightly related. What we did in the past is we actually allowed you to build a binary in a prefix, and then actually install that in a different prefix on a different system, and it would actually adjust the prefix. We stopped doing that because it has a lot of issues. So as long as you keep the prefix path the same, you're good. If you change this, of course, you should also use compiler flags that say use generic CPU, all that stuff, right? But as long as you keep the path the same, it probably is going to work very well. If you try to change the prefix path, you run into all kind of very complicated issues, because the paths are very often hard-coded everywhere into the program. So basically don't do that. We went away from it. We had the sophisticated software solutions to try to relocate the binaries, but we went away from it because it is not reliable enough. You better just bootstrap them for a different location.
Mm-hmm. And you say make sure you build generic, but I think that's what Prefix does by default, right?
It depends a bit on the profile. I think the default flags is -02 or something. That should still be generic. Yep. But for instance, in the Mac profiles, we use -m arch equals native. And if that would be the default on the Linux profile too, then you are going to build for the processor that it sees, right? Yeah. So you don't want that. You definitely want, I think, -02 at most, and that's it.
Yeah, it's not using march native on Linux. We're sure that we would have seen that already, but it is doing that in macOS.
Yes, because I put it in there, because on macOS there is, well, macOS controls its ABI so thoroughly that we could just do that, because you have the press code in the core to duo, and the next CPU would be able to support those instructions, so it would be a +1 basically.
Okay, but you have to bootstrap on the oldest hardware.
Yeah, but the thing is that if you say macOS X, so macOS 10 point whatever, comes with an SDK that actually demands the macOS minus version, and the compiler actually knows that it only contains that CPU as minimal, so it will not do anything there. Yeah, Apple did a great job in many things. It also did a not so great job in many other things. But some of these things actually are very nice. But that's, beside the point. You just run into it when you do something like this.
Okay. Yeah, I'll pass the mic to Bart, who has a question as well.
Yes. Hello, it's Bart speaking. My camera is not here, so you have to just hear me. Can you hear me? Just to make sure.
Yeah.
Yeah. Okay. This first thing, just to say, it's a great project, Gentoo Prefix. We're using it in Compute Canada right now. It's like opt-in on the cluster, but we're making it default environment as of April. And so what happens is that people load it via environment modules, and then it overrides most things of the underlying CentOS distributions on the cluster. And that's all distributed via Steve Invest, so it's read-only. But while we're doing Gentoo Prefix installations, we found out we had to override various kinks in the cable, so to see some small issues that pop up. We've also shared that with the Easy project. And one thing is that on CVMFS, everything is read-only. But Gentoo Prefix puts everything under the prefix, including coding things paths that start with /var. They're putting in prefix /var, and sometimes that doesn't work. Like we have tools like who, finger, who am I, all these things that have to do with login authentication. They then read files that are written by the host OS in /var, but they don't read in var. They read in prefix /var, and these are empty, and there's nothing in there. So we had to basically put in some symbolic links to work around that, which seems a bit ugly. And I'm just wondering, has there been some thought into that, or should I open a ticket to have some discussion about that, how to fix that properly?
Yeah, this is a very interesting. So the initial objective was do as little as possible with the host system because it is possibly crap, basically. What you're mentioning is some tools that yeah, Finger I think is a long old deprecated tool, but okay, those kind of things. That is indeed where you question, is Prefix the right approach that you want to do? It is writing,
Yeah.
reading.
Yeah, no, I agree that Finger is old, but on a cluster, who is a command that executes many times because you want to know who is logged in on the cluster.
Yeah.
You just don't get the same information.
Yeah, and I'm actually wondering because I run who also a lot. I'm just the who. Okay, I provide who and it just works. Yeah. So we have who, and I don't understand. I don't know why who doesn't work for you from Prefix without modifications, but I do think that. So long story short, I think you have a very specific scenario. Making symlinks in that scenario is not a bad hack, so to speak. The thing is, if we can identify the underlying things that you would need, we could see whether or not we could make that configurable somehow. But on the other hand, you say you have a read-only root, so perhaps it needs a bit more though anyway. So if it certainly might be interesting to actually have a look at this, if we can pinpoint what exactly you need. My gist is that you do have a very specific use case of it though. And we can always try and see if we can provide alternative e-builds or something for the overlay. That will do exactly what you want.
And I think it's very specific in the case that it's probably a setup that's specific to HPC sites, but it's a problem that any HPC site will have. So it's specific to HPC, which is definitely niche. We're fully aware of that, but it's still a lot of people. It's not like a single use case.
Oh, I wasn't.
What happens in this case that who will sort of work, but it will not give the same information. Like it will just give the list of usernames, but who has some extra information like where they logged in from. So they tell the IP or the host from where people logged in from, like their IP or the university from, and that information is stored in a file /var/run/utmp or wtmp, one of these files. And the host OS stores the information in there, and then who reads in turn from those files. So the only thing is like we need to sort of either have a symbolic link or teach Gentoo Prefix, and I think that information actually comes from glibc, so you need to put in some flags in the glibc compilation, which tell you that. So I'm just wondering, we need to have some discussion. This getting a bit too technical for this talk, but what would be the right place to approach you guys? Is it a bug in Gentoo.org or somewhere else?
Interesting one, right? Because it works for me without any. It gives me exactly the same information back.
Yeah.
But it would be interesting to see why, and maybe the base layout can just provide this, because UTMP, that one can probably be symlinked once during the setup or something.
Yeah, that's what we do now.
Yeah. And by means, start a discussion on this. I know that Benda is also in HPC land, so, and Amanio, so. They might be having some good ideas about this.
Okay, thank you.
Any other questions by anyone else, Simon?
That seems to be all the questions I can see at the moment.
I have a couple more, but maybe it's better to move to the breakout room so we can. Oh no, we actually have time, right?
We have time, yes. We have a couple more minutes here if there are any.
Well, yeah, it's 10:02, so let's make sure Bob can get set up, and we'll wrap it up here and jump to the breakout room. I have a couple more questions for Fabian if he's up for it.